GPT and Llama models and Hugging Face. So all of those generative AI, it's based on the large language models. It's also a context of large language models, small models as well. So what it is, it's a deep learning algorithm that can understand actually it can understand text, and it can understand pictures, it can summarize the content for you, it can translate languages, it can predict some of the words. It also can, as I mentioned, like generate pictures too. So when we talk about the AI models, it's just a couple that I named, but it's actually so many of those. Maybe I'll just enable my laser point here. This is on a service. It's called AI Studio in Azure, and as you can see, like here's quite a few models available, and every day when you log in, it's something new is adding. Some of them are better, some of them are faster, some of them are more expensive too. Each model has a unique strength and in use. So what are the limitations of those models? If you deploy any models, even ChatGPT, you probably heard that, well, it doesn't have up-to-date knowledge. So when you talk about internal knowledge, it's going to be the same problem. And what do we do? It is three ways. Well, in this slide, three ways. I don't want to guys confuse you. But it is one more actually available. It's called Raft. We'll probably mention that, but maybe in the future presentation, we can present it as well. So in order to bring the knowledge to our application, you can either do prompt, which is not really an application. So the way prompt works, you have some context, and then you ask the question. It can answer based on context, but this is just one time. So if you already find the information, you try to answer, like it's not the best way. So these two ways, the fine tuning and the trivial augment generations, are usually the most common ones. When we start to compare the fine tuning, what is the difference? So the fine tuning, this is actually when we prepare a lot of data, question key pairs is like almost the question and answer, and then we analyze it, we check for different biases, and then we train the model. The challenge with this is going to take more time, and it's hard with the dynamic data. If your data is changing often, you won't be fine-tuning all the time. So that's why it is this RAG component came up, architecture, where instead of fine-tuning, we can use services like vector databases, where we can pre-populate the data, and then we can retrieve the data that we need and ask the model to summarize on what we retrieved. In this case, the knowledge is temporary. Like it doesn't, our LLM model wouldn't know, like it's almost summarize it and then forget about the data. Any questions so far? Okay. This is a basic diagram how the RAG application works. So we have some data, whether our structured or unstructured data. So when we have the data, the processing mechanism it's called an embedding model. So what embedding model does is actually converting your, whether it's a pictures or text or structured data, to numbers and store this on the vector database. Because when we have numbers now with the pictures and everything, it's easy to find information. So when this is data available in the vector database, this is how our query works. So when we have a question, it's actually before sending anywhere, it'll go to our embedding model, translate your question to the numbers, search on the vector database, and return back. And this is kind of our prompt engineering here, where we have the context, some instruction, we have the data from the vector database, and also our question on top. And now we send this bundle to the large language model, and we get the result. This is the at high level how the RAG application works. So we'll describe kind of each component.
May I ask one question?
Yeah.
Yeah. So this is regarding this vector database. So Any kind of special requirement for this vector database? Because we know that there are like graph database as a physical different structure. So because I've seen like you can use any database as a vector database. So could we just throw some light on the underlying kind of database engines which can be used for vector DB?
Yeah, so Wilson, I'm not sure if you can help me. It's actually, or maybe when I finish, I'll send this link. It is a very great link on Microsoft Azure. Even they're recommending, as you mentioned, it's a multiple vector databases, and some of them, for example, the latest one that was a couple of weeks ago update. It's on the Cosmos DB. They added a new feature, and now it's pretty scalable too. And it has almost like in which case to use which database to make sure that you get the most performance and scalability, and also the cost as well. So I'll share that. Maybe it'll provide a little more information there.
I think one of the main takeaway there, Roman, is it's not just a vector database that you need. Is the vector database also contains the algorithm that compares the numbers that Roman mentioned. So it's not just you cannot just throw it into a simple SQL database, for example. It has to have the capability to calculate um, the comparison and find the correct value output for you essentially. But I'm sure Roman will dive into some of that as we go through the example as well.
Yeah, thank you,
Okay.
Wilson.
I have a question. So is this drive going to be temporary memory? A vector database, I understand. I can store in the vector database. So is this a permanent thing, or it gets flushed out over some time?
So with the vector database, this is permanent, right? But when we send to the model here, this is almost like the model would reply back to you and it wouldn't capture this information, so it'll forget. Unless we build some memory integration, which is another option as well.
Please re-explain, because if it is stored in the vector database, then every time it will talk to the vector database and it is permanently stored. So why do I need to have a separate layer for memory?
So the memory you would use, imagine a scenario where you want to check what your customer says. And for example, instead of like doing this from every time from the beginning, you can also say, well, he already asked these questions, and maybe like based on that history, you can have provide a better response. You wouldn't be capturing, you wouldn't be like, it is a way, again, it's not a part of this demo on the memory side, but you can almost like pass, hey, can you capture this last two messages that customer asked? And then let's provide the most relevant information to the customer. Because the customer maybe like with the previous answer is not satisfied, and it can trying to like the customer trying to change the question.
Okay. Yeah, because in ChatGPT, if I upload a file, and then I still get those questions related to that file. So, it is not temporary. That's what I'm asking.
So in ChatGPT, I think it's actually it's a good question. How the GPT, I think. Yeah, go
Hey
ahead,
Roman,
Wilson.
I just gotta jump in here. Maybe let's chat a little more about this. I think there's some confusions between the top part of the diagram and the bottom part. So, for ChatGPT, when you upload the documents, right? That's more what you see on the top, the embedding model and the vector DB, right? I think what Roman is trying to explain on the bottom part is when you ask a question to ChatGPT, that question, yes, is remaining on your thread, but it doesn't remain cross-thread. If you remember early on in ChatGPT deployment, there's no such a thing as called memory until very recently, right? Until I think after 3.5 came out, right? So I think that's the distinction between the two. The question that you ask is the query and the context prompt. But where your document that you uploaded that they store the memory is the part on the top with the vector database and the embedding model.
Right. That is right. That is fine, because what you're saying is that document is permanent, but the question is transient, so it will keep changing. There's no memory for the question.
Right. There's no memory for the question in this case. So if you want to build that chain, I think it's what's happening. It's something you have to build on top, right? Which It's not something that's directly out of the box. Correct me if I'm wrong there, Roman.
No, that's exactly it. And that was a great example, Wilson, because even when if you use ChatGPT back in a day, it didn't, like now, for example, it would remember your name before it wouldn't.
Yeah,
Okay.
did that answer your question there, Amit?
Yes.
Awesome.
Okay, so Wilson kind of cover each pillar here for the factory components. Like I'll maybe talk a little bit more about the data science in Fabric. So as you can see in one
I have one more question. Can you explain again the difference? Because this is again confusing. Fine tuning and prompt engineering and prompt fine tuning. Is fine tuning and prompt fine tuning same?
No, it's not. So when we talk about prompt, it's almost like when you go to ChatGPT and you said, well, this is my context, can you answer this? But it's almost like you're providing this manual information. It's not really relevant here. But this is more like fine tuning when you need to actually prepare a lot of information, at least maybe 10,000 questions and answers, and then you train the model. So now the model will be permanently know all those questions and answers. But it's some downside, as we mentioned, the dynamic data issues, but also because it has so much information to answer to you, like it has so many answers, it might hallucinate. So what it means, because it's so much information, maybe sometimes not really relevant information that I can provide.
So are we changing the weights because there is fine tuning and there is prompt fine tuning?
Are you referring to the retrieval and fine tuning?
No, I'm only talking about prompt fine tuning. So fine tuning is a
Oh,
concept. Yes.
I see what you mean. Actually defining the prompts, right? I think this is what you mean. Not the model specific, the way you ask the questions on the prompts, right?
Yes, right.
Okay, yeah, we'll cover this a little bit as well. It's not the same fine tuning. This is where we're talking specifically about the model itself.
Understood. So when you say models, you're saying you're basically changing the weights of the model, the last layer or the last one layer.
Yeah, so when we do the fine tuning, it's going to be specifically here on the model. When we're doing RAG, we're basically doing a lot of heavy lifting here, right, for the embedding itself. And then we creating this prompt, as you mentioned. And inside prompt, this is going to be your specification. What instruction do you want to give to this prompt? So then you can get the better results that you're looking for. And then you send all of this prompt to the large language models. In this case, it will receive this data.
Are you showing anything on the slide? Because there's no marker. It's just that the slide is there. You can't see anything if you're drawing.
Okay, sorry. Is it better? Can you see it?
Yes, now I can see.
Yeah, so when we're talking about the fine tuning, if we do, it's going to be happening here only. And in this case, if you do the fine tuning, it's going to be more permanent knowledge. But in the RAG, the way it works is actually, as I mentioned, we do the data preparation here on the vector database. We combine this data based on the query happened, retrieve the data, we combine it together as well as the context, your instruction, what they want to send to the model, like it's together, it's called prompt, right? And then your query, and then you send all of this to the model. In this case, the model wouldn't remember what you sent. It will just, again, in time, see the context, the instruction, and the question, it will reply back to you and forget about what you ask.
Fine.
Okay.
Thanks, Roman.
Yeah, no problem. So when we talk about the data science in Fabric, so data science, because all the components already have integration between them and the single data foundation with the one lake, it's easily allowed you to connect to different sources, analyze and visualize, process the data, build models too, and collaborate together with different developers. This was the data scientist pillar here. You can run different notebooks. It is one more part that I want to cover this a little bit. It's called the SynapseML library for the machine learning. So the purpose is it helps to create the large-scale machine learning projects easily. It also helps to use it for text analysis, image recognitions, and it runs on the Apache Spark and can handle lots of data. It's flexible, and because it's open source, it has a deep integration with Microsoft services, and it's supporting different languages like Python, R, Scala, Java, and .NET. And as I mentioned, like the integration layer connects to, you can easily connect to different databases and the cloud storage. Some of the requirements, it needs to have Scala 2.12 and Spark 3.2 and Python. So for this specific demo, we prepare a couple of notebooks. In one of the notebooks, we're going to go through embedding process, where we would use the data that Wilson prepared for us, and then we will use the embedding model to convert this to the numbers, and then we will, in this case, our vector database AI search, push this data to the AI search, and then on the second notebook, we'll just do the validation. So we'll connect to the AI search, we use the model, and just try to transfer the data. So right now, the Fabric doesn't have the option to deploy the application itself, for example, the prompts. Maybe in the future series, we can cover the AI Studio, the prompt flow, and the deployments. So I'm going to jump to my demo, or maybe like before I jump, do you guys have any other questions? Okay. Okay, do you guys see my screen, the Fabric here?
Yes.
Okay.
Yeah.
Okay, so I'm gonna go to this notebook, which is to create the indexes. The first thing what I'm gonna do, I'm gonna add the lake house that Wilson created. So I'll do the existing one because I don't need to create a new one. So it's gonna be this. To save a little bit of time, so I'm gonna run all, and then maybe I'll go step by step for each kind of line, and then walk through you guys. So as you can see on the first line, we are importing the Synapse library here, and then we're also importing some other necessary libraries for our notebook. On this notebook, on this cell, we are defining, actually maybe I should have jumped a little bit back. So for this specific demo, we are using key vaults. This is where we can securely store all our secrets. So instead of exporting this in a notebook, this is the AI search. Right now, we don't have any indexes yet, but this is what we'll create. And then it's also, there's multiple ways to deploy models. One of the options is use the OpenAI service. Another one would be the AI Studio. In this case, we'll be using just the OpenAI Studio. I'll just maybe go quickly here and just show you some of the models that we have deployed for this demo. It's so if I go to our deployments, This is the small model we deploy for the embeddings, and then we will be utilizing the GPT-4 for our chat bot as well. So in this specific cell, as I mentioned, we don't want to explore any keys in the notebook. So we leveraging key vault. We define some of the parameters for the models that I show you and the AI search. So it's already was able to connect and to the key vault and grab a couple of secrets. Also define some parameters, the name of the lake as an example here. So in this notebook, the data that Wilson created, we are reading that table and we are displaying the 10 rows. So in this specific cell, we are creating the formatted text column for embedding based on existing data. And here, we are preparing the embeddings. And maybe I'll talk a little bit here on embedding itself. So we're actually saving them in the table. So we're gonna double check when this step is done. We want to make sure that we don't have any errors. It's just a small simple check here to one command line to see if we had any errors. In our case, this cell just completed, so we don't have any errors. It looked pretty good. And then the next step is going to be using the iSearch API to add the data, create the index, and then add the data. I'll maybe go jump a little bit here. So we also define, I'll probably share a link as well at the end of presentation. Oops. It has multiple ways to propagate the data, or maybe like select the proper size. It depends on the case. And in our case, because it's all structured data, so we don't need to have a very big size. And the embedding length, it's usually you would select based on what model is supporting for the embedding. So now in the creating the index in the vector database, we already had some of the data that are some of the tables in the table that Wilson prepared for us. So technically, we could just push only the content and the embedding itself, but we're also including the order ID numbers, order date. The reason we want to do this, maybe not for this specific POC, but it's also like if we push to AI search, we can use different mechanisms to retrieve better results when we specify, for example, in some of the searches, it might be more interesting if we want to focus on order ID line ID, order line ID, so it can provide us better results there. So as we can see, the index was created. I'll go maybe here to the vector database. So let me see. Okay, it's populated now. And then in this specific call, we are the data that we prepared before. Now we're actually going to write this data to the vector database and present some of like 8 tables. So this is completed, the notebook one. So we should have some data now. I don't know, maybe I'll just try a couple of numbers. As you can see, the data is the data is populated.
Roman, can we maybe talk a little bit about why we are forming those strings and how is AI search storing those data?
How is the AI search?
Yeah, I think there's some terminologies. I think there's a difference between like when we operate things in the data engineering space versus in the AI space. So, like if my understanding correctly, for AI search, everything is referred to as documents, right? Where we operate a lot of times like based on roles in data engineering.
Yeah, that's correct, Wilson. Let me see what I can add here. So I don't know, maybe Wilson, you can help me to talk about the difference, because in the documents, as an
Yeah.
example, it's a little bit different strategy how you prepare the data. Like for example, with the documents, it's called chunking strategy, and you can do some overlap how you propagate the data so we can see it's almost linked to the previous stage, where in an engineering side, I don't think you have that. It's also like
Yeah,
on. Go ahead,
that's a
Wilson.
good point, Roman. That's one thing I struggle with when I was working on the demo, and I think it's good to point out for the audience here is um as Roman pointed out earlier, there's a maximum length that you can store for the embedding model to work correctly. As he showed on in the code, there's a length limit that he specifies. So it's important that we understand each of the embedding model, like what Roman talked about. It has different length that we can encode our data. So once when we exceeded that code, that amount, the encoding model actually will yell at us and saying that, hey, your string is too long, we cannot process it, right? So it's important, like what Roman's saying, you got to pick the right model for your task. And for us here, we try to make sure we don't exceed that amount, right? So a lot of check needs to be put in place to meet the embedding length of 1536, for example. And in terms of loading it into the AI search, as what Roman mentioned earlier, in the AI search screen, we need to first create the index, which you guys saw. But more importantly, we need to write each of the role data into AI search. And I believe there's different terminologies there. In data engineering, we refer everything is just mostly just like a database, right? SQL rows, right? Everything is a row. But in AI search, I think under the indexes, um, they call them documents because on the left you saw like this 1,793 documents. So I think each of the row becomes a document, and then AI search generate the index size for you, right? If I understand that correctly.
Yeah, that's correct, Wilson. That's correct. Maybe to add to that as well, it is a different mechanisms how you can do your vector profile. So in our demo, we're not using it's called a semantic wrapper, which actually allowed you to even more better search results. And it also has different algorithms. Again, for this demo, we didn't want to overwhelm everyone, but it's also something we can do like a deep dive maybe in the future sessions on different algorithm mechanisms. What is the best practices for different type of searches too? Okay, do we have any other questions? Okay, I'll proceed to the next notebook here. I'm gonna touch the lake. And I'm gonna run all the code while we're going through. Similar what we've done the previous notebook, we did import the necessary libraries, and then we did preset some configuration here. And in this case, it's very important to make sure we use the same length that we were using for the indexing here in our search when we're going to be using in our RAG component here. So you have different configurations. So this is specifically for the models itself. The key, the service name, and the model that we have deployed. And this is specifically for embedding, and this is the other configuration specifically for the chat. As you remember, like on the service, we deploy the GPT, I think it's 4 model, actually. Oh, yeah, GPT-4, the one that we're using, and this is the parameters we're passing here. So in this scenario, we're just doing a sample question and converting the sample question to the embeddings. So I'll probably go here. This is where we call in the vector source that we have with the index and with the data. It has some specific configuration. We are asking to provide the 75 of the top results. It can be also less. It depends on the use case. So in this case, we were able to call the AI search based on the question that we defined, and we got the 75 top matching results. So now what we're doing, actually, from the retrieve top results, we have a function to generate the chat response based on the large language model and the context. And I think this is what Amit, you mentioned. So this is the prompt engineering where you can provide the instruction. And then in our case, as you can see in the context, this is actually going to be the AI search results. And then it's going to be our instruction. What do we want the model, the instruction to resolve? And then we're also providing our question here, the one that we defined. And then based on this information, this is basically your prompt engineering here. We can get the results here. So those are the results based on the ID that we ask for the order ID. So for the last, for the worker ID for the last 3, that was what the customer was buying. Here's also another question, question number 2. And here's the results that we're getting. And we also, based on the practice, because keep in mind, this notebook is not for the live application. It's more for the engineer to validate the indexes, to make sure it's performing well. And then we can also double check and go directly to our table just to confirm the data that we did in those here is actually matching on the table too. So that means our indexes in the AI search and on the table are up to date. It's looking good here.
Yeah, I think it's a bit of a growing question, right? So at the beginning, we asked the AI about just to retrieve us the order yourself. So we keep it pretty simple, try to make sure the AI chatbot is smart enough to give us the order yourself. Right? We're being very specific in the first inquiry, where I think something that's very powerful in the AI chatbot is in the second query, we're being very generic. Instead of saying it's an alien officer hoodie, all we said is an alien hoodies. We didn't tell a ChatGPT that Oh, can we scroll back down to the bottom for a second, Roman? We didn't tell the ChatGPT that how many items we want to return. We just say we want to return everything, and it was able to understand that because the return is $245, and since we specified the policy in our prompt engineering that we can, as a customer service rep, you cannot return, I believe, more than $150, if I recall correctly in the code, that it's telling you that you couldn't actually return it. So if we scroll down just a tiny little bit there, it would tell you that we couldn't return it because it was more than $150. But it also tells you that if they want to return the mug, that you can. So um, I think furthermore, if I'm not mistaken, there it also shows that the customer service supervisor can return it for this. So if you have an escalation process for you to your boss for the customer service department, then everyone is following policies. The customer service department supervisor can help this customer really quickly here instead of us trying to fumble around, try to find this return and then try to find the policy and then the right person to return this information here. So I think that kind of it's important to show that it is not we don't have to tell it exactly what the information needs to be, but it's the language itself can be interpreted relatively well in this case, which is pretty cool, I think.
Yeah, and to your point exactly, Wilson, because otherwise, imagine writing those queries for specific cases where now if you go to our vector database, almost just providing the as little information can go and search for us instead of writing those queries all the time, right?
Yeah.
So now when we have, I'm not going to go through too deep on this, but also it is even in OpenAI service, you can have a component which is called chat. And you can add, let me go and change the model here. It looks like it's not working for me anymore. It was just working a couple hours ago, but we should be able to add our data for the index that we created in the AI Studio, and we should be able to play with different parameters. I'm not going to go through the parameters itself, but it's like some of the parameters are help you to remove some hallucinations to provide better answers, but you can also start testing data more in depth and maybe define your best prompt engineer here. And this is the system message that I think, Amit, you were asking for, and you can play a little bit more and define what you're looking for. You can also deploy a web application from here if you want to. Okay, I think that is it from this presentation. So I'm gonna.
So yeah, so to wrap this up, after all this we went through, we learned quite a bit about Microsoft Fabric. It is a new technology that Microsoft has released very recently. So we're glad to be able to showcase that today. It's important to take away that it is a SaaS platform, so it has all the services that you need built in. No longer require you to set up for a variety of services for your AI and data and AI tasks. There's still some gaps, right, as you can see, but it's getting there slowly. We also showcased that we can use Dataflow Gen 2, which is a low-code solution to integrate, ingest, and prepare the data for our embedding. We Roman showcased that we can use the data science notebook and the SynapseML library in order to generate the embedding for us using a text embedding model in OpenAI. Uh, we created the embedding, generated the text for the embedding, and then we can store all the information in the AI search, which is your vector database that Roman pointed out earlier. And that database is able to find, the results for us as we doing based on whatever query we pass in, acting as a customer service agent. We can use ChatGPT model 4 to respond to the chat based on the results that are coming back from the AI search. So that's kind of our end-to-end demo there for today. The code repository, so this link is not going to be working today as we're dealing with some outages this today, as you guys can saw on the news. But we'll try to get the code up in the environment in about a couple of days' time. So maybe give us about a week to get the code up and available there. And hopefully by the time also the video will be up as well, right? So hopefully that will be kind of happens in the same time. But yeah, that would be the location for it. It's in the GitHub repo, Wilson-Mock, and in the long strings, given that GitHub has kind of changed some of the structures there. Okay. And then finally, we just want to thank you, everybody, for coming today, and welcome Roman for our first presentation, which is awesome. And if you guys want to add us, feel free to add us through the QR code to our LinkedIn profiles. And yeah, thank you for everyone for attending and hosting us as well on the Dear Azure channel. And have a great afternoon and evening for those that are in North America.